What's going on, everybody? Mr. Diamond back again for a very short video this time over power. This is coming right after the work energy theorem and talking about what work and energy is. And while we're here, it's just a convenient time to define power. Like I mentioned in that video, we're going to come back to power much later in this chapter. But while we're just getting some of these definitions of these basic ideas out of the way, it's probably just for the best to get this kind of over with. So power is a measure of work being done to an object over time. Or, because of the theorem we just mentioned, how much energy is exerted over a given period of time. It's work or energy divided by the time that it takes for that work to be done. So since power is work done over time, we have a unit of joules per second. That's called a watt. But I want you to notice kind of this chart really breaks down a very good explanation of the difference between work, energy, power, and how they are all connected. One interesting thing about power is power explains why you get more tired when you do something quickly. So for example, running up a flight of stairs is going to take a certain amount of energy. There is a certain amount of work because you have exerted a force to get a body of you over a certain distance. So the same work and the same energy would be done if you sprinted up a flight of stairs, like it says right here, or if you walked up a flight of stairs. Work and energy both only care there was a force done, it went over a certain distance. Notice that time is irrelevant for that. Power cares about time. So if you run faster, you're exerting more power, and that's going to make you more tired versus if you're walking up the stairs, which would use less power. Because you're doing that same amount of work, you're going up the stairs, which is the thing that requires work, at a faster pace. And that faster pace means you use more power, even though it's going to take the same amount of energy. It seems a little bit weird because power and energy and work all, again, seem kind of related to each other. And in day-to-day life, you may use them kind of interchangeably. But to kind of go through this flow chart just a little bit more clearly and break down the other parts here. So work is a force applied times a distance moved, and that's like the physics definition of it, at least. It's done whenever a force is used to move something, like open the door, lift groceries, climb stairs, or throw a ball. Energy is the ability to do that work or to exert a force, and work can kind of in some ways be used to measure energy done. We'll talk more later in this chapter about exactly how to do that. Power is a measure of how quickly that work gets done. It's work divided by the time taken, which is why running up the stairs will take the same energy and take the same work, but they will take greater power than walking up the stairs. The faster you do something, the harder it's going to be for you to do, not because it takes more energy, but because you have to do that same amount of energy in a faster pace, which means you're using more power. So an example of this that I can show the work for it, but it's really, really straightforward. If we go back to our rocket ship from earlier, we could ask how much power is used to move the rocket. Well, power, like it says right here, is just work divided by time. And if I go back to my rocket ship picture, we calculated that it was approximately 1,000,000 joules, or 1,000,000 joules was our answer to our calculation. But it says it takes 60 seconds. So if we were to do our 1 times 10 to the 6th, or 1,000,000 divided by 60, we would end up with 1.67 times 10 to the 4th joules per second. That's joules of energy every second are being released or being used. And so that unit, again, joules per second, would be watts. There are 1.67 times 10 to the 4th watts of power that are used to move that rocket ship. So that's what I've got for this first section here. The key idea, other than just that definition of power, is this right here. That doing something faster doesn't take more energy, it takes a higher amount of power to get that done. Another way you can kind of think about this, I guess, would be like if you had a box that weighed like 500 kilograms, you could in theory pick that up like pebble, like piece by piece, like if it was full of rocks. You take one rock up and down, up and down, up and down, and up and down, or you could lift the whole box. Technically, that takes the same amount of energy to get done, and that takes the same amount of work to move the whole thing up to the top. But power-wise, it's going to take a lot less power. A really weak person could move a box rock by rock up to the top of a hill, but a very powerful person would be required to lift the entire box and carry it up to the top of the hill. So that's what I've got for this very brief video. Hope that makes sense to everybody. If you have any questions, please shoot me an email. Otherwise, this is Mr. Diamond signing off.